Good evening, everyone. This is Milena Chenna, and I'm currently pursuing my BTech from the Law Institute of Technology in the field of computer science and engineering. Today, let us look at the data structures in blockchain. What is a blockchain? A blockchain is a distributed database that is shared among the nodes in a computer network. As a database, a blockchain stores information electronically in digital format. You can think of blockchain as a digital medical record. Every record is a block which has a label stating the date and time when the record was entered. The medical history is extremely important for diagnosis and treatment purposes, so neither the doctor nor the patient should be able to modify the records that has already been made. Nevertheless, the doctor owns a private key which allows him to make new records, and the patient owns a public key that allows him to access the records anytime. This method makes the data both accessible and secure. Blockchains are best known for the crucial role in cryptocurrency systems such as Bitcoin for maintaining a secure and a decentralized record of transaction. Now let us understand how blockchains are useful in cryptocurrency systems. Whenever there is a transaction which takes place, there are several steps that it undergoes in order to get completed. The first step is authentication. Every transaction has two parties. One is the sender and another being the receiver. The transaction between these parties is authenticated using cryptographic keys. These keys are nothing but a string of data, more or less like a password that identifies the user. There are two keys, the public and the private. Everyone can see the public key, and the private key, as the name suggests, can only be seen by the user. Using both the keys, the user can unlock the transactions that they want to perform with the step, a block that basically represents the transaction is created. Now that the transaction is approved between the user, it needs to be authorized. For this, the majority of the nodes must agree that the transaction is valid. Therefore, the block which has the current transaction is sent to every node that is recent in the network. Now, there is an interesting point to be noted. People who own the computer in the network get the rewards. The process is known as proof of work. They are required to solve complex mathematical problem in order to add a block to the chain. The process of solving mathematical problem is known as mining, and the one who mine are known as miners. The miners get rewarded for the work they do, normally in the form of cryptocurrency. This is how blockchain plays a crucial role in cryptocurrency systems. After this, the block is now added to the existing blockchain. The innovation with the blockchain is that it guarantees the fidelity and security of a record of data and generates trust without the need for a trusted third party. Now coming to the difference between a typical database and a blockchain, as we can clearly see in the diagram given below, in blockchain there is no central authority and modifying data is nearly impossible. But in case of a typical traditional database, selected groups of individuals have authoritative control and data or assets can be easily exchanged. So we can see that the data or the activity in a blockchain is out in open for everyone to see, which cuts down the excessive costing. But in case of a traditional database, all data or transactions are hidden from each other, and implementing the process is really costly. A blockchain collects information together in groups known as blocks, that's whole sets of informations, and blocks have certain storage capacities which when filled are closed, and they are also linked to the previously filled block, forming a chain of data structures known as a blockchain. But in case of a traditional database, databases are they are really faster because user 2 cannot see what user 1 is doing. Basically, all the data or transactions are hidden from each other, and implementing cost is costly. So the databases are comparatively faster. Now, a database usually structures its data in form of tables, and it is stored in tabular format. Whereas in case of a blockchain, it, as its name implies, structures its data into chunks known as blocks. This data structure inherently makes an irreversible time of data when implemented in a decentralized network. Basically, what happens is the traditional databases are used in organization where there is mutual trust. But in case of a blockchain's data structure, it is used in organization where there is no mutual trust between the users. Whenever a block is filled, it is set in stone and becomes a part of this timeline. Each block in the chain is given an exact timestamp when it is added. Now coming to the blockchain data structure. Blockchain structure is a combination of two hash-based data structure. One is the linked list and the second one is a Merkel tree. Linked list, in linked list, this is a data structure of blockchain, which is a linked list of hash pointers. And a regular linked list consists of nodes. Each node has two parts, the data and the pointer. The pointer points to the next node. In blockchain, simply replace the regular pointer with a hash pointer. Merkel tree is a binary tree formed by hash pointer named after its creator, Ralph Merkel. Now we can see in the diagram listed on the right side is a linked list of the data structures. Blockchain data structure can be viewed as a linked list, and each block within the blockchain references a previous block known as the parent block in the block header. So blockchain in the linked list is built with hash pointers instead of normal pointers. In linked list, you have a series of blocks, and each block has data as well as the pointer to the previous block, as we can see in the diagram on the right hand side. So in blockchain, the previous block pointer is replaced by the hash pointers. So each block not only tells us where the value of the previous block was, but it also contains a digest of that value that allows us to verify the value has not changed. The sequence of linking each block to its parent creates a chain going back all the way to the first block ever created, known as the Genesis block. In fact, the parent block linking is what makes the blockchain immutable. Now we can see a diagram that is listed over here. The first block is known as the Genesis block, and it is followed by a series of blocks. That is the first block, that is the second block, third block, fourth block, and each block consists of a list of transactions. And in the below part, we can see that there is a representation of a block which consists of a multiple transaction and a block header. Basically, each block consists of a header section and a body section. The header section of the block may consist of the information that is the Merkle root, the nonce, the timestamp, and the hash of the previous header, the version number, and the difficulty target. The body section consists of the list of transaction, which is represented in the diagram. The hash of the block header of the block is in form of a 32 bytes, that is 256 bits, using SHA 256 algorithm, which stores as a hash of the previous header as a part of the block header of the block of n+1. Both look like a list connected with a link, we can see. But in a linked list, the link is termed as a pointer, and the pointers are variables which stores the address of subsequent node or a block, but it is used to navigate between the next node. This last node consists of a null pointer, which means that it has no value. Similar is the blockchain structure, that is, it is in over here the link is termed as a hash pointer, and the hash pointer is not only used to look up to the previous block of the transaction, but it also helps us to verify the transaction that is stored in the previous block is not tampered, and the hash pointer is the hash value of the header of the data of the previous block. So a use case of blockchain is a tamper evident log. It helps us to build a log of a data structure that stores a bunch of data and allows us to append data onto the log and detect if somebody has tampered or altered the data. Now coming to blockchain as a Merkle tree. The data transaction in this block are not stored in form of a plain text. Instead, they are stored in form of a data structure known as Merkle tree. Merkle tree basically stores all the transaction in a block by producing a digital fingerprint of the entire transaction. It also allows the user to verify whether the transaction can be excluded in the block or not. Every transaction in this Merkle tree is uniquely hashed by hash pointers or functions like MD5, Blake2, SHA1, SHA256 to produce a digital fingerprint of the entire set of transaction. The process follows as in, we can see over here on the right side of the diagram, there are 4 transactions. The Merkle tree of transaction A, B, and C, and D. But the hash of the Merkle tree is ABCD, which is the root hash. So basically what is this is, suppose there are 4 transactions in a block in the diagram given below, and it consists of 4 transactions which has unique hash of its own. Then each transaction is paired in form of a like transaction A and transaction B is paired, and their hash is stored in the above transaction. We can see that is hash AB. Transaction C, the hash of transaction C and the hash of transaction D is again paired and stored in the form of a hash in the above tree, which is known as the hash CD. On the other hand, we can see that the hash AB and the hash CD are then grouped together by the hash function to produce the hash ABCD, which is the Merkel root or the Merkel tree. And the Merkel root is stored in a block header. Basically, in a Merkel tree, the data blocks are grouped in pairs, and the hash of each block is stored in a parent node. The parent nodes are in turn grouped in pairs, and their hashes are stored in the level up. This continues all the way up to the tree until we reach the root node. So we can also prove a proof of membership. That is, it allows us to prove that if a block, how to understand if a data block is included in the tree or not. For this, we can only need to show the blocks and the path from the data block to the root. For example, if we need to show that if transaction A is included or not, we should take a route. We can ignore the rest of the tree so that the blocks in this path are enough to verify the hashes all the way up to the root. Another one important thing is, like, if we have n nodes in a tree, only we need to only show the log n items need to be shown, and since each step requires computing just the hash of the child block, it takes only about log n time for us to verify this. Now, coming to the key takeaways from this video. Basically, we have learned that blockchain is a type of a shared database that differs from a typical database and the way it stores information. Blockchain stores data in blocks, whereas traditional database stores data in the form of a tabular format in form of tables. As new data comes in, it is now entered into a flesh block. Data basically is in form of transaction, and multiple transactions are grouped together in form of a block, and then they are added to the blockchain. Once the block is filled with data, it is chained to the previous block with the help of hash pointers, which makes the data change together in chronological order. Different types of information can be stored on a blockchain, but the most common use of this has been a ledger for transaction. Therefore, blockchain is known as a immutable ledger. In Bitcoin's cases, blockchain is used as a decentralized way so that no transaction or person or group has the control. Rather, all the users collectively retain the control. As a result of which, in blockchains, there is each node has the authority of all the transactions that are being viewed. Decentralized blockchains are immutable, which means that the data entered is irreversible. For Bitcoin, this means the transactions are permanently recorded and viewable to everyone.